Identify the two chiral carbons in the molecule. First, we want to add in our hydrogens, and we can eliminate any atoms that have two or more hydrogens attached because they cannot have four unique groups if they have two or more hydrogens. And then we need to look at the remaining atoms. When I look at carbon 2, I see that it has a fluorine group, hydrogen group, CH3, and the entire rest of the molecule to the right of carbon 2 as its last group. Therefore, this will be a chiral carbon. Now I'm going to look at carbon 4, and I see that it has an OH group, a hydrogen group, a CH3 group, and the rest of the molecule to the left of carbon 4. Because I have four unique groups attached, I see that I also have a chiral carbon. Identify the one chiral carbon in the molecule. First, let's add in our hydrogen atoms so that we can eliminate any carbon that has two or more hydrogens as a possibility for being chiral, which eliminates carbon atoms 1, 2, 4, and 6. Now we can look at carbon 3, and we see that we have a fluorine group, a hydrogen group, the CH2CH3 group, and the rest of the molecule to the right of carbon 3. When I look at carbon 5, I see that I have a CH3 group, a CH3 group, a hydrogen, and the rest of the molecule to the left of carbon 5. So carbon 5 is considered achiral because it has two CH3 groups attached, while carbon 3 is considered chiral because it has four unique groups. Is this a chiral compound? First, we want to draw in our hydrogen atoms so we can eliminate any carbon with two or more hydrogens. This allows us to eliminate carbons 1, 4, 6, and 7. We can also eliminate carbons 2 and 3 because they are involved in a double bond, and if it's involved in a double bond, the atom cannot have four groups attached because it has two bonds which take up one group. So our only option left is carbon 5. Before we can establish if this molecule is a chiral compound, we have to see if carbon 5 is a chiral carbon. So we need to look at the groups attached to carbon 5. We have a hydrogen, a CH3 group, a CH3 group, and the rest of the molecule to the left of carbon 5. Because we have two CH3 groups, this would be an achiral carbon for carbon 5, and as a result, it is an achiral compound. How many chiral carbons in this compound? First, we need to add in our hydrogen atoms so that every carbon has four bonds. We can then eliminate carbon atoms that have two or more hydrogens because they cannot be chiral. So this eliminates 1, 3, 4, 6, 7, and 9. The only atoms that remain to check to see if they're chiral are carbon 2, 5, and 8. Let's look first at carbon 2 and look at the groups attached. We have an OH group, a hydrogen group, a CH3, and the rest of the molecule to the right of carbon 2, so it has four unique groups attached, so carbon 2 would be chiral. Next, we're going to look at carbon 8, and we see we have a hydrogen group, a CH3 group, and an OH group, along with the rest of the molecule to the left of carbon 8 as its fourth group. So we see that carbon 8 is also chiral because it has four unique groups attached. Next, we're going to look at carbon 5 in a little more detail. First, let's circle each of our groups. So we have a hydrogen, a CH3 group, the molecule to the right of carbon 5, and the part of the molecule to the left of carbon 5. When you look at these two groups on the left and the right, be careful. The group on the right has 3 carbons, and the OH group is on the second carbon from carbon 5. When I look at the group on the left, I see that it has 4 carbons with OH on the third carbon from carbon 5. So these groups are different, so this is a chiral carbon at carbon 5. So carbons 2, 5, and 8 are all considered chiral carbons.